I told you that stoichiometry would become more complicated, right? Well, when I say that, I just mean the steps. The steps are going to take more. If you've learned everything up to this point and you feel pretty good about what we're doing math-wise, then I don't think stoichiometry will be a problem for you, right? You just got to kind of keep your act together, and you just got to make sure that everything dimensional analysis-wise is set up the proper way, and you've got it, right? Don't take any shortcuts. Don't do this, oh, let's do this and this and this and divide by this. No, because that's where you're going to screw up, right? So take the time, do dimensional analysis, set the problem up the proper way, and that will fix all of these mistakes that could happen. So previously, I drew this roadmap up here at the very top. And this roadmap basically said we can connect two things together in an equation. Doesn't matter what two, we can connect two things into an equation together. And then I also said, I kind of gave you a little bit of, future sight predictions, I guess, in a way, of where these problems are going to go. So as long as I've got these mole ratios, I'm fine. But I also said that what if we threw you a curveball and we maybe threw grams into the picture? Or we asked for grams in the other picture for the product. How would we handle that type of scenario? No different. There's no difference. You already done these problems. The only thing that you're doing is you're adding one more step in. That's it. And you saw how easy that step was in the last video. You just got to look at the equation and balance it. And you got it. And then I told you that I'm going to give you the balanced equations every time. So I'm not going to say I'm baby feeding you, but what I am saying is that you're overthinking stoichiometry for the most part. If you've seen this in Chemistry 151, or maybe you're learning it now, who knows? Maybe you've already seen it and you didn't understand it, and now this is your second revisit to it, and you're scratching your head and you're wondering, well, what was my problem back in the day? You didn't have a problem. It's probably the way that it was explained. All right, so let's take a look at an example. I'm going to show you these aren't really any more complicated than anything else. So 2HCl plus CaOH2 will give me 2H2O and CaCl2. So we're going to do a stoichiometry problem here. And it says, let's imagine that I had 0.684 moles of HCl. How many grams of CaOH2 would be needed? This is very similar to what we did last, except instead of mole to mole, it's now mole to gram. Same steps. Nothing new here at all. Everything that we're getting ready to do, we've talked about in a previous video before. So I take my given, 0.684 moles of HCl over 1. Mole of HCl on top, mole of HCl on the bottom. And I need to go from mole of CaOH2. Now, you're probably stopping and you're probably wondering, well, that's not what the question wants. The question says you got to go to gram. I'm getting there. I got to go through this detour first, right? Look up here at this roadmap. I'm starting off with mole of HCl. There we are. If I want to go to calcium hydroxide, which is something completely different, I've got to go through this detour. I've got to go and use the mole ratio first to get to mole of the other substance that I'm interested in. If I don't do this step now, I'm not going to be able to connect any of the twos together. I've got to do the stoichiometry part first. Then when I get there, when I get to that mole, I can then use the formula weight to go to gram, which is what the question needs. So follow the flow chart here, right? Mole of one substance to the mole of the other, and then into gram if that's really what you need. And that's what we need here. So I go up to the equation. CaOH2 is right here. It's number 2. There's not a number in front, so it's understood to be a 1. Hydrochloric acid, HCl. There's a 2 out in front, so a 2 is going to go there. Now we're not done. Normally, in the last video, that's where we would have ended up. But I need to now go into gram. So mole of CaOH2 on top, mole of CaOH2 at the bottom, and I need to get to gram of CaOH2. Well, in order to do this, I need the formula weight, right? That's what it tells me up here. I can go from mole to gram to mole, as long as I know the formula weight of the substance. So we're going to have to kind of do a side calculation, and we're going to have to do the formula weight of CaOH2. This is an example calculation we did back in the day, previous videos before. We talked about how to go from one to the other, and you did some assignments on it, right? Nothing new here that's getting introduced. The only new piece was the mole ratio right here. All of this other stuff is old news. Who cares about it, right? We know how to do this. No sweat. So let's calculate the formula weight of CaOH2. So we have seen this periodic table before. And the atomic masses are up in the top left-hand corner in this version. So we need Ca, so that's right there. So that's 40.08 plus, and then we have OH2 in parentheses, right? So the OH is in parentheses, and there's a 2 on the outside. So that means that we have 2 oxygens, so 16, 16, and 2 hydrogens, 1.01 and 1.01. And that gives me 74.10 as a formula weight. So 74.10 gram in 1 mole. That's all there is. Now my setup is complete. So I'm going to bring back up the calculator, clear it out. 0.684 divided by 2 times 74.10. And I hit enter, and I get 25.34. So 25.34 grams of CaOH2 would be used up if that's how many moles of HCl that I have. All right? So a simple fact of going from mole of one to mole of the other that I'm interested in using mole ratio. And then this time bringing in formula weight just to take that extra conversion step to get to a physical number of grams that I could maybe weigh out or measure in a laboratory. All right, so let's erase that, but let's keep this same equation up. And we're going to do all over again. Hopefully that works for you, because it works for me. All right. Next example. What if we had 0.684 moles of HCl? We're going to keep that number the same, right? I don't want to change too many things on you. Again, I want you to focus on the process here. 0.684 moles of HCl. How many grams of water could be formed? All right. Same kind of setup, no difference. Take my given, 0.684 moles of HCl over 1, mole of HCl on top, mole of HCl on the bottom, and I need to go to mole of water. That's the molecule I'm interested in. I got to do a mole ratio here. So from the equation, hydrochloric acid has a 2 in front, so a 2 goes there. Water also has a 2 in front, so a 2 goes there. And now, mole of water on the bottom. And the question wants me to go to gram. So I know that that requires formula weight. Grams to moles, moles to grams need formula weight. So I need the formula weight for water. Well, that's 16 plus 1.01 plus 1.01. That's 18.02 grams in 1 mole. You just did stoichiometry, people, in less than 1 minute. That's all there should be to these questions. So 0.684 times 2 divided by 2 times 18.02 equals 12.33 grams. And you got it. So if I use that many moles of hydrochloric acid, I should end up with a little over 12 grams of water from the reaction. If I did this in the lab and I get close to 12, I'm good. That means my percent yield is very high. If I do this reaction and I have less than 12 grams of water and I report that number, then somebody's going to question me on what I did. Why wasn't it close to 12 grams? That's what it should be. That's the theoretical number. That's the theoretical yield. That's what we're doing here. In theory, you should get a little over 12 grams. Why didn't you do it? And we got to go back and we got to look at our processes. We've got to look at our techniques and figure out what exactly happened. All right. We're going to do another example. Again, using the same equation. I'm focused on setup and process. That's all that I'm doing. So we'll get rid of this and we'll try it again. So in this one, we want to know if we started off with 0.684 moles of hydrochloric acid, how many grams of CaCl2 could we get? All right, 0.684 moles, time me, of HCl over 1. Mole of HCl, mole of HCl on the bottom. We need to go to mole of CaCl2. HCl has a 2 in front, so a 2 goes there. CaCl2 doesn't have a number, so a 1 goes there. And now mole of CaCl2 to gram of CaCl2. So I need the formula weight of CaCl2. So here's my calcium, 40.08. My chlorine, 35.45 plus 35.45, because there's 2 of them. That gives me 110.98. So 110.98 grams in 1 mole. There's my setup. 0.684 times 1 divided by 2 times 110.98. And I get 37.96. So 37.96 grams of CaCl2. Took me less than 2 minutes, about a minute and a half here to solve that problem. That's all that stoichiometry should be, right? Connect the 2 steps with each other through the equation. And then whatever kind of curveballs they throw at you after that, it's fine. Go gram to mole. You can do that. Go to molecules. You can do that too. Doesn't matter. Or what if they didn't give me mole here in the beginning? So what? Who cares? You can do that mess. What if this was 0.684 grams of HCl? Well, if that's what they decide to do to try to make my life a little more difficult, then they need to try a little bit harder, because the setup would only change into something that looked like this. I'm not going to fill in the numbers. I'm just going to kind of do the setup. So if they gave me 0.684 grams of hydrochloric, 0.684 grams of hydrochloric, and they wanted grams of calcium chloride. All right, well, put that over 1. Gram of HCl on top, gram of HCl on the bottom. All right, I need to go to mole of HCl. That's the only thing that I can do in the roadmap, right? So I need the formula weight here, 35.45 plus 1.01. Well, okay. And now I have mole of HCl. I can go to mole of CaCl2, 2 in front, 1 in front of that. And then I've got mole of CaCl2. I can go to gram of CaCl2, as long as I know the formula weight, and we've done that one in the previous video. That's the only extra step I had to do, was this very first one. Take the gram, convert it to mole. And then when you get to mole, you can then do whatever you want to with it, just like before. That's the only extra step that we had to do with this one. So don't let those types of questions throw you off. Just keep in mind, mole is the key. You got to get into mole before you can relate any two things together in that equation. So if you've got to convert gram to mole in the beginning, then do that separately. If that's the way that you want to do it that way. Or I like to just chain everything together in one-dimensional analysis problem. But that's up to you. Whatever works best for you, whatever you feel the most comfortable with, do it that way. No one's going to judge, right? So in this upcoming assignment, these are the types of questions that you're going to see. It's going to say you're starting with this many number of grams. How many moles could you end up with? Or you're starting with this number of grams. How many grams of the other stuff could you end up with? Or you're starting with this many number of moles. How many grams of the other stuff could you end up with? Right? It's just pieces of the puzzle. That's all there is to it. So you're typically going to see a mole to gram step, or you probably could see a gram to mole to gram step. We leave off molecule. We just don't do a lot with molecules a lot. And I just don't want to worry you with that scenario. I think that's kind of silly. It's there. We can do those types of calculations. On a sheet of paper, it's great. In 151 or 152 chem course, we're probably bombarded with those types of questions. But in an actual laboratory, we just rarely go that route. So, gram to mole to gram, or mole to gram. And I think that you'll be okay. So in the next assignment, those are the types of questions that you'll see. Good luck to you. I think that you'll be okay. And if you've taken Chemistry 151 already and didn't quite get it, I hope that you've learned something in these couple of videos in about 10 or 20 minutes worth, more than maybe what you got all semester worth in one of those types of classes. So if so, good for you. And I wish you luck, and I hope that you do much better here than what you did before.